numericals, we will do little recap what we have done in previous video. Okay. So first of all, what we had discussed last time, here 1 mole is equal to, if I ask you in terms of number of particles or number of molecules, you will write it is 6.022 into 10 to the power 23. Okay, it can be different kinds of atoms, molecules, or particles. This number is also called Avogadro number or constant. If I ask you 1 mole is equal to what mass of that particle or atom or molecule is. Okay, so it is just going to be equal to its relative molecular mass. It is going to be equal to molecular mass, or you can say gram molecular mass. And if I ask you 1 mole of gas contains what volume of gas? It can be any gas, and as we had discussed in previous video, this is applicable only for gases. So at STP, that is standard temperature pressure, it is going to be 22.4 liters. But if it is, this is at STP, standard temperature and pressure, which is going to be how much temperature it is? 0 degree Celsius. Okay, and pressure, how much pressure we are getting? It is around 1 atmospheric pressure. Okay, but we will be using room temperature pressure, RTP. For that, 1 mole of gas will have 24 liters or 24 dm cube of volume. If it is in centimeter cube, you will take 24,000 centimeter cube, and this is at RTP. For RTP, room temperature pressure, we are taking temperature around 25 degrees Celsius. We know that on Earth, generally temperature is fluctuating, but pressure at sea level, we are getting 1 atmosphere only. Okay, so this much we are aware of. So now we will discuss how we can use this concept in numericals. Okay, so this numerical, we have taken this from your past papers. So in this case, it is saying, understand question properly, you need to read it properly. Dilute sulfuric acid reacts with magnesium to release hydrogen. Here this equation is given to you. Understand, first of all, you need to check whether it is balanced or not. If not, you have to balance it. But in this case, if you see on right hand side and left hand side, you can see this left hand side of this arrow, this is the reactant, and this is the product. So according to law of conservation of mass, this number of atoms, or you can say mass of all the reactant, must be equal to mass of the product. So here you see there are 2 hydrogen on reactant side, product side also it has only 2 hydrogen. 1 magnesium, 1 magnesium. Sulfate ion, if you see SO4, it is 1 time only. Here on the product side also it is only 1 time. So equation is balanced. So we don't need to worry about this, but not necessary. In many questions you have to do that. Now your question begins. Your question begins. Complete the steps in the calculation below to find the volume of hydrogen gas that is produced when 0.072 gram of magnesium reacts in excess dilute hydrochloric acid. So here first of all they are asking, in step 1 what we have to do? Calculate the number of moles of magnesium. Now question may come. They are asking question related to hydrogen, but then why we need to find out moles of magnesium, because here they have given you mass of magnesium. Okay, they have given you mass of magnesium. Once we know how many moles of magnesium are going to be used as reactant, so we can correlate how much or how many mole of product, that is hydrogen gas, is going to form. In this case, you need to understand here 1 mole of magnesium is producing 1 mole of hydrogen. So whatever number of mole of magnesium you are going to get, same number of mole of hydrogen you are going to get in product. Now we will find out how many moles of magnesium we are using. So first, you know that number of moles of magnesium equal to given mass. I'm writing formula, given mass divided by relative molecular mass. See, in this you will be getting periodic table. In that you can check what is the mass of magnesium. Okay, you know that it is 24. So here 0.072 is the given mass of magnesium, and mass of magnesium, its atomic mass, you know, it is 24. So when you divide this, you are going to get here 24 times 3. That will give you here your final answer, number of moles 0.03. Okay, so here we are getting how many moles of magnesium? We are getting 0.03 moles of magnesium. Okay, this much is clear. Okay, so now once you know there is 0.03 moles of magnesium which have been formed, so same number of moles of hydrogen will also be there. Why so? Because magnesium and this hydrogen are in the ratio of 1:1. This is for your understanding. Okay, magnesium and hydrogen, they are in the ratio of 1:1. So if magnesium is 0.03 mole, so hydrogen will also be in 0.03 moles. Okay, this much you understood. So next step is to calculate the number of moles. So here state the number of moles of hydrogen gas produced when 0.072 gram of magnesium react. So we have already discussed that in previous slide, but again, just for your understanding, we can say, since ratio of magnesium used and hydrogen produced is 1:1, and magnesium is 0.003 mole of magnesium, which is going to be equal to number of moles of hydrogen. So you will write here 0.003. But during exam, you don't need to write all these things for 1 mark. What you will do? You will just write 0.003 mole, since they both are equal. Okay. Now, next question, if you see, here they are asking, calculate the volume of hydrogen. So you are aware of that we already discussed. While recapping, I was talking about this. 1 mole is 24 dm cube. So our hydrogen is how many mole? It is 0.03003 mole. So volume is going to be, volume will be equal to number of mole multiplied by 24 dm cube. Okay. Okay, children. So now you know that volume of hydrogen gas is equal to number of moles of hydrogen multiplied by 24 dm cube. You can make this formula triangle for volume. If you have to find out volume, that will be equal to number of mole multiplied by 24 dm cube. Okay. So if you have to find out number of mole, so it is given volume divided by 24 dm cube. Okay. So this is how we will be substituting now. So number of mole is equal to 0.003 and you will multiply 24. Okay. So when you multiply this, you will be getting 4 3s are 12. Okay. 3 to the 6, 7. Okay. And 3 decimal places. So 0.072 dm cube. Next, here they are asking state the name given to the number of atoms contained in 1 mole of magnesium. So for that, you know that you will write Avogadro number or constant. Okay. So this was the application of that mole concept to solve this numerical. We will be adding many more numericals further in next video. Okay. For today, we'll keep up to this.